Hello everyone, we are live. I'm Permal Jagan and we are streaming some Sherlock solving stuff here. Um, in my previous stream, I started solving a Sherlock called Latus from HackTheBox. For those who don't know what is Sherlock, it is all about solving a digital forensics and incident response challenge, completely a blue team stuff. And we were started solving Lattice in last stream, and I was able to answer a couple of questions, only couple of questions, and we found what we need to look at next to answer the remaining questions. And we found the thing like it was about RDP. Now we are going to do that. We are going to solve. We are going to crack some DPAPI encrypted stuff. So that's what I've planned to do in this particular stream. Okay. Without further ado, let's start. Uh, now we are seeing my screen, and you are seeing a blog of SpecterOps. I found this blog couple of days ago. I think it's released in July 28th this year. I think before few days, and it's an incredible blog. It explains about the fundamentals of DPAPI and how we can crack that DPAPI creds. So let's see. Let's see the challenge once. The challenge is Lattice, and it's a hard challenge. Uh, it was about the RDP, and you can read the scenario here. And we were given the backup of the C drive of the victim system. And if you read through the questions, it is predominantly asking some RDP stuff, the RDP related details. So we need to uncover the files that stores the RDP info from the given artifacts to answer these questions. All right, that's what I'm planning to do here. You can see the notes. I did some research like how DPAPI encrypts and decrypts the data. So I actually managed to crack all these things, like the reference links and the images. um, I mean, just at higher level, as a blue teamer, you need to understand how it encrypts and decrypts, and what sort of keys used in this encryption and decryption. Though you need to have that high level idea of this DPAPI encryption and decryption. Like, okay, let's see what is DPAPI. Data Protection API. It is offered by Windows. When you give some data to when you have some data to encrypt or encrypt, then you can simply ask the DPAPI via an API call to encrypt some stuff, and it does the rest. It encrypts, and it throws the data to you. When you need to decrypt, you are again asking to decrypt just via a system call or an API call. Then it decrypts and gives the data to you, the plain data to you. I think that's all about this DPAPI. It keeps it simple, and this DPAPI is actually used by many applications, because it actually ties this encryption with that particular user's credential. Let me tell you, we will read through this blog. It is actually a worth reading. So let's read through this blog completely. At the end of this read, you will be having an idea how the encryption and decryption happens. DPAPI backup key compromise. Some forests must burn. So they are talking about this backup key, but I'll come to that point later. But before that, let's dive into this. They actually mentioned about this DPAPI compromise. We will come to this part later, but we will start from here. DPAPI background. At a very high level, DPAPI provides a simple interface for encrypting sensitive data. The interface allows application to tie sensitive data to a specific local machine or specific user. It does this by including local machine or user information as part of the data protection process. For user encrypted DPAPI data, DPAPI uses one or more user master keys, which are formulated using user's password. So what happens here? DPAPI actually crafts a key called master key. Actually, this master key is crafted by using the user's password, right? The user's password is actually used to craft the master key, and the master key will be used to encrypt the data or decrypt the data. So if you want to decrypt a data, then you need that user's password. So by using that user's password, you can crack the master key. Once you crack the master key, you can use the master key to crack the encrypted data. And that's the concept here. These type of master keys are used to protect DPAP data, and they actually referring another blog that explains about this the DPAP stuff, but you can read through that, but this blog is enough to understand this DPAP for now. DPAP uses master keys to protect data. As I said, master keys must be decrypted before they can be used to unprotect the DPAP data. Master keys can only be decrypted with the user's password or domain backup key. So here is the thing. The master keys are involved in the data encryption and decryption, but to crack the master key, you need either user's password or domain backup key. Master keys can be many because when you change the password, the master key will change. The user's password often getting changed, right? So at the time the master key can change. Master keys will be changing, but the domain backup key is just one key. It cannot be replaced. If it is compromised, then you need to reset, you need to wipe the whole domain and you need to rebuild it from the scratch. And that's what this blog is all about. DPAP backup key compromise, some forest must burn. That means they are talking about rebuilding the whole domain. I hope you got it. Then DPAP protection is used anywhere. I'll tell you how. And you can see the list of some of the applications that use DPAP. Google Chrome. To store the Google Chrome data, it uses DPAP. Microsoft Edge, of course, and Firefox. You can see the three major browsers that we know. And ASP.NET Core Windows keys. Some Windows secrets being stored by using DPAP. Skype data, Azure, Microsoft 365, credential manager stored in Windows Cred Manager, RDP creds, and this is what quite important. So that's why I was talking about DPAP from the beginning while solving this challenge. So we will be cracking some DPAP RDP secrets by using DPAP. By using DPAP master keys that we were given, and they see the Outlook email password, these things. DPAP domain backup keys are keys which can be used to decrypt any master key in the domain, and that makes this backup key is a trump card to crack the whole domain. This makes the backup keys incredibly powerful. Due to sensitive nature of these keys, it is imperative that access to these keys to be protected and regarded as one of the most highly confidential pieces of information in the entire Active Directory domain. And you can see the importance of domain backup key here. This insecure design is unintentional. Master keys are tied to user's password. So in the event of a user forgets the password or the user password reset by an admin, DPAP data protected with the password would be lost. So that's why this backup key brought in. The user's passwords are often changing. It could be lost. In case of that password loss, the data must be recovered, and for that you may use domain backup key. All right. Microsoft implemented backup keys to guarantee data accessibility. Therefore, if an attacker has access to the DPAP domain backup keys, they have the mean to decrypt any master key that they can obtain. In case of DPAP backup key compromise, if the attacker has access to the any DPAP protected data and the master key which was used to protect the data, the attacker cannot protect the data. I think they are mentioning about the importance of the domain backup key, and that's what they mention here. So if the domain backup key, the DPAP backup key is compromised, then the whole domain is compromised. You need to rebuild from the scratch. Again, I'm repeating. Can't we just rotate the keys? Ignoring Microsoft advice, the natural instinct might be to look a way to rotate the domain DPAP backup keys. And why there is only one domain backup key? Why can't be multiple or just a rotation of the DPAP backup keys? And they have some reasons for that. So let's see. There is currently no officially supported ways for changing or rotating these DPAP backup keys on the domain controllers. In the accordance with the document, third parties have the ability to develop an application or script that creates a new DPAP backup key. So Microsoft officially do not support DPAP backup key rotation. And you can see the reason one. They actually gave three reasons, I suppose, for not having the rotation facility of the DPAP backup key, the DPAP architecture. Microsoft documentation suggests that the third-party tool could rotate the keys by generating new backup key and setting that key as preferred key for the domain. This process technically accomplishes rotating the DPAP key. However, and the way DPAP currently works, all current master key would still be encrypted with a compromised backup key. The attacker would still lose the access to the new keys generated. Okay, what they are trying to say, if the compromised domain backup key is actually encrypting the master keys, the master keys that are already available, then at the time, if you rotate the backup key in case of compromise, it is not possible to recover the existing master keys with the newly rotated backup key. I think that's what they are trying to say here. They're giving it as a reason. For a tool truly rotate the DPAP, we would have to generate a new DPAP backup key, set a new keys as a preferred key for the domain, set new key as the preferred key for every domain user on every host. Okay. These are all the steps involved in the DPAP backup key rotation. And the next reason is compromised master keys. Let's pretend Microsoft did support rotation of DPAP backup key. If the adversary compromised or exfiltrated any master keys during their attack, those master keys would remain compromised. Changing domain backup key does not alter the key material that is used to protect the data. So this is the second reason. And the third one is the advice we've been ignoring. Up until now, we've been putting aside Microsoft recommendation, but this recommendation is the strongest reason for abandoning the car. Okay, if an adversary has compromised the DPAP backup key, so they are giving this particular reason as the strongest one. The adversary has spent some amount of time in the environment with a privilege equivalent to the domain admin. They had sufficient permission to make whatever the modification they wanted to the admin. So, I've already gone through this. So let me explain this in a brief way. If an attacker compromise a domain backup key, as a security researcher, we could understand like the attacker spent some time in the victim environment. So at the time, it is apparent that just rotating the backup key would not restore the whole environment to the old state, or it won't secure the environment in a complete way, in a complete manner. So I think that's the reason they are giving. That's the ultimate reason they give. It is still compromised because they spent some time in the environment. They spent some time in the network, so they would have changed something. So it is not possible to restore every changes that the attacker did completely, and that's the thing that I wanted to mention. And there they gave bunch of references to it. But now let's go to another blog and see how we can decrypt this stuff. There are multiple tools available to encrypt and decrypt this stuff, but we are going to do it from a Linux machine. So I'm just referring some of the commands that they gave and also the locations of each key. Let's see first. Is there a way to extract the values of the secrets? What tools we can use? Focused on Linux based solutions, and this is what we need. Key hierarchy and decryption flow. Boot key or sys key. Yeah, 128B value derived from system registry Hive unique to each Windows system. So what they are trying to say, they are mentioning about the boot key. Boot key is actually present in the system. I think it is in the system Hive, system registry Hive. The boot key is derived from the several values and the LSA key stored in the security Hive and used to decrypt the specific LSA secrets, including DPAP level, DPAP system related secrets. Once the boot key is obtained, it decrypts the LSA key. So they are actually talking about the boot key to encrypt the LSA key stored in security Hive. Okay, is decrypt the specific LSA key, including once the boot key is obtained, the decrypts LSA key. LSA secrets. The following secrets can be found among others: DPAP system, which contains the DPAP machine and the user key in local DPAP. Okay, so it's a bit confusing to me. Computer account credentials. So they gave some locations where this LSA secrets getting stored, or I think each highlighted string denotes a secret. And I go to the next one. You can see the location of the master key that gets stored. So they actually mentioning about the system master key, and there are two type of master keys: system master keys and the user master keys. User master key is stored in the every user's directory, while the system master key is stored in this particular directory in system32 Microsoft Protect. Under that security identifier, they store this system master key, and this is very important to decrypt the data. And RSA machine keys located in this particular directory. All right, let's move on. RSA machine private key encryption using impacket and sharp dpappy. So we can use the impacket utility dpappy.py to decrypt this secrets. So that's what they are talking. Extract system and security register hives. So we need these security and system registry hives to extract the password, I guess, the password of the user. I think that's what we did in the first stream. If I scroll down, I think I would have taken that. I think I should have taken that notes here. Let's see where it is. Yeah. Look at this one. I have used secrets dump, and I got the system and the SAM hive, and I've loaded it to the secrets dump, and from the system hive it actually extracted the boot key. The boot key is required to decrypt this SAM hive. So I managed to extract the password hashes of every user, and while I load these password hashes, I was able to crack one password, the password of A08D, that ends with A08D. So everything is ends with A08D. Let's see which one is I'm dealing with. Is it same first? Yeah, both are same. emman.t, emman.t and eman. So looks like it uses the same password, eman 2024, and that's the password we already cracked. So this is the process. It's quite simple. You should be using the secrets dump. First of all, you should be having these two registry hives. Then use the secrets dump against those registry hives. Extract the hashes, load it into the hashcat, crack the password. So we already got the password. Now we can extract the master key, because the master key is encrypted by using this user's password. So we can now extract the master key. Once we extract the master key, it is possible to pass the master key into this dpappy utility, and we can try to okay, look at this one. What they are doing here: decrypt each system master key using impacket. So this is the command they are using to uncover the master key, and you can see the way they are uncovering it. And get SHA-1 hash of the decrypted system master key. Okay, so this is the master key. This is where they are passing the master key, and they are actually changing its form to SHA-1. They're getting the SHA-1 hash and extract the private keys you want to decrypt. And what they are doing here, they are installing sharp dpappy, and they are passing the machine key and the master key. Okay, run sharp dpappy. This it's a little bit confusing. Let's see. Do I see any other commands? dpappy.py unprotect file blob. Okay. So this one is to uncover the master key. dpappy master key file, and they are passing the master key file, and they are mentioning the password and users security identifier, and eventually they get the decrypted key with the user key SHA-1. So they gave that SHA-1 stuff. And dpappy unprotect blob key. Okay, so here, so this is the command. They pass blob as well as the key that they obtained from the previous command, and they actually use it to unprotect the data. Awesome, awesome. Now I think this is okay. Now let's understand what is this. DPAP allows decrypting majority of DPAP secrets, credentials, vaults, DPAP blobs. The following example shows the official decryption, offline decryption of DPAP blob retrieved to call the cryptographic data in the context of user. Okay, so if you are on a local machine, then you can simply, I mean, if you need to decrypt the data of your current machine that you are in, then you can use this stuff simply. So it will refer internally all those master keys and the password, those things. If you are doing it offline, I think you need to use these two commands to decrypt that. So this is what we are going to try now. Let's do it. So we already obtained the password. The password is iman 2024. Let's do this. Let's try to identify the files. Okay, first of all, let's go and check the location of master key, domain backup key. Location of domain backup, sorry, no, okay, let me tell you. I think I should be checking that particular user's master key. Let's see, to answer some questions. See this one. Iman.t is very careless, always saving RDP credentials to connect with other host. So they're talking about the habit of the particular user. So since that particular user is saving the RDP creds, so we need to look at this particular user's directory. Let's see. Okay, I go here. I go to Latus, extracted, and this is where I'm holding the evidence. Users, users iman.t, and here I'm actually holding a particular directory called app data, and this is where the dpappy stuff gets stored. App data, local and roaming. We need to check both. Local, if I see local, let's see. Do I see any interesting stuff here? Local Microsoft, and I'm seeing some folder called credentials. So this is where the secrets are hidden, I guess. Credentials and vault. So for now I need to focus on these two directories. So let's see first. Credentials. Do I have any? Yes, I see bunch. I could see bunch of entries here. Awesome. Okay, then how about vault? Let's see. ls-la vault. Here I'm holding one blob, user profile roaming. Okay, let's see. I guess if I search here, I'll do one thing. I'll go to this particular users directory, and from here I use tree. Still I see bunch of data. I think it's annoying. Iman.t, yeah. Oh gosh. All right. Now within app data, looks like the user was using the Brave browser. That's what shows all these PNG files, some artifacts. Let's scroll down. Come on. It's going forever. Chrome shutdown, Chrome component. I was seeing some RDP stuff. So first of all, I need to get those files. Okay, first I'll do one thing. Where it is? Yeah, I'll do one thing. I go here. I create one directory for a particular user, iman.t. Okay, and for this user, I think I need to grab the relevant files. Let's see. Okay, I go to the previous tab, and from here I'm actually going to roaming, and in roaming Microsoft, I should check the protect. So this is where the the master key gets stored. If you get into this SID directory, and you could see the list of master keys, and you can see there are multiple master keys because the password might have changed. You can see the credhist file. This is what storing the passwords that previously changed. So this is an encrypted file, so we need this file as well. Now let's try to copy all these files. Maybe I'll copy everything here. Okay, I go here, cp everything to Sherlock's Latus iman t. So I need to do one thing. I need to create one directory, Sherlock's Latus iman.t. Here I create a directory called master keys, probably like this. Yeah, and I'm executing this command, master keys. All right, now it will work. If I see, okay, I copied everything perfectly. All right, now I've copied all these things. Moving on, I need this credhist and synchhist file as well, so I'm copying these two as well. Copy credhist to Sherlock's Latus, Sherlock Latus, that particular username. I guess this makes sense. Master keys, can I store here? Okay, no, I'll store it in this users directory itself. Awesome. How about another file, synchhist? So I have no idea. I need to learn about that synchhist file, but this is fine for now. I have copied all this data. I've copied the private key of I've copied that master key of that particular user. All right, now this is fine, this is done. What else? Anything else do I need to check here? I have the files credentials and vault in this roaming directory as well. So let me copy this particular thing as well. I go here. I'll do one thing, make directory roaming, and move credhist to roaming, sorry, move synchhist to roaming, move master keys to roaming, sorry, roaming. Yeah, all right. And now I'm creating one more directory called local, like this. So I'm just trying to grab all the relevant files in one directory so that it will be easy for me to refer those files while decrypting the stuff. CD roaming Here I have these master keys. Then what else? Okay, I go to this particular pane. um, Credentials and vault. Okay, awesome. One, make dir credentials and vault. Credentials, make dir vault, like this. Okay. I go to credentials. In credentials, do I have anything? I don't have anything here. Come on. Vault, do I have anything? No. Fine. I think in this folders, vaults and credentials, the the Windows credential manager stuff gets stored. Credential manager. So those details get stored in this particular credentials and vault directory. But as far as RDP concerned, we should be referring some different directory. But I'm just grabbing all this secret data somehow. Before that, let's see. I should go to local. In local, I'm seeing Microsoft, and in Microsoft, I'm seeing credentials. Let's decrypt this as well. Okay, I'll grab all these things and store it somewhere. One, I get into local. In local, can I see? Okay, I'll create a directory. Credentials. Make their vault. Sorry, a typo. Okay, I go to this pane. Move. Sorry, not move. Copy everything to Sherlock's, Latus, local, or Imanti, local credentials. Okay, done. Moving on. Vault. I'm also copying this. CP, everything, Sherlock's, Latus, that user, local, vault. Awesome. What? -R. Okay. -R. All right. I look it is okay. Now let's see where the RDP stuff gets stored. I should be copying those files as well. I guess I should be googling here. Location of RDP data stored in Windows. Let's see. Current user, Microsoft Terminal Client servers. Let's see. Terminal server client. Cache. I could see some data here. Let's see. I'll search terminal server client. Yeah. Just one entry. In one entry, I could see this data. So I guess the RDP details are stored in this particular blob. So let's bring all these things here. Make dir Sherlock's Sherlock's Latus iman.t and here I'm creating a directory called RDP, and let me copy every file into the directory. Awesome. Now I move on. I go to this, sorry. Okay, I guess I should be moving these things towards, okay, let's make dir or backward slash one path behind, and I'm creating one directory called protect. So because I need to store my master keys separately, so I'm just creating a directory and then moving master keys protect like this, and similarly I'm moving redhist file to this directory and sync to. Awesome. Now we got everything that we need. Now let's use this particular dpappy command to decrypt the stuff. Yeah, I found this one was relatively easier, and I'm going to try the same here. Let's see. So they are actually trying to decrypt the master key here. So let's see this. Let's try to decrypt every master key we have. We go to protect folder, and this is our first task. We are having that user's password, so let's use it to decrypt the stuff. Okay, so we have 5 master keys. I don't know what this particular file is all about. Let's Google it. Oh, sorry. It is showing some car model. Windows dpappy. What it is? Windows dpappy refers to the combination of what? Is a security feature in Windows. dpappy used to encrypt the data such as passwords, often utilize applications. Windows dpappy derives the encryption key from the credentials password. Okay. And you can see that Windows API dpappy crypt protect data. So this is the function that is called when the data to be encrypted, and crypt unprotect data is the function to be called when it has to unprotect the data. Just an information. Okay, now let's go and craft the command. I copy this command and let's do it here. I go to the end and I add a title, decrypting. Oh gosh, decrypting master keys. Okay, awesome. This is the command. I mentioned one master key here like this, and password should be Iman 2024. Okay, and the security identifier of the user. Can I see the security identifier of the user? I guess I should see it here. Let's see. Roaming Microsoft protect. Yeah, so here is the security identifier of the user. So let's copy this. Okay, I copied it and I got just one command ready to decrypt this. Let me use the same command to decrypt the other keys as well. Okay, I'll copy this. 2, 3, 4, 5. Okay, and I'm replacing second key. Third one is here. Um, okay, fourth one is here. Fifth one. All right. Now let's execute this command one by one. Um, okay, I stay here. I execute this. Let's see. Error. No such file or direct. Come on. Okay. Now it will work. And look at this. It decrypted the SHA-1 hash of that particular master key. I think we have this hash now, but similarly we need to do this. We need to do it for the remaining stuffs as well. Now let's see. I store these things. So this is the first master key, and moving on to the next one. This is the second one. We managed to uncover this. This is the second master key, and the third one. Okay. Now, yeah, I could grab the next one. Okay. Then fourth one. Let's see. Yeah. Yes, we uncovered this one as well. Then the last one. Yeah. And now we have all these master keys ready, and let's use this master keys to unencrypt the blob. We are already having that RDP blob, so let's try it against the RDP blob we have. And this is the second command we should be using. So it's quite simple. Let's copy this command. So I think I should be creating a title here. Decrypting RDP blobs. So the encrypted string, they call it blob. Awesome. So this is the command. And now I should be using the blob detail against the master keys that I have. Okay, now let's grab the blob detail. We go here to RDP directory. Within the RDP directory, we are seeing bunch of blobs. What about this BMC? I have no idea. Let's see. Bitmap cache parser. No place to hide. Forensics challenge. BMC. I could see a forensic write-up in HackTheBox. Let's see. I got 2 files. Okay, I don't know what kind of these files. I searched for the file in Google. Okay, look like the cache bin file. Look like a file signatures header x RDP. This is actually the RDP data. And what about this RDP 8 BMP? Because of that, I knew it was cached file of BMP images. I searched around the Google, found that I got the Python script to get those files. So there is a utility to crack that BMC file. Okay, I think in this challenge, the context was totally different. It was not about RDP. It was about some cache file, some blob along with that BMC file. I guess they actually encrypted an image, a BMP image, I guess. Okay, now I go here. Um, try to uncover these blobs. Okay, let's do it one by one. First, I mentioned this blob detail like this, and the key. The first key that I got, I use it. If it doesn't work, then I should be using the second blob. So the second key, 3, 4, 5. So I'll be creating a 5 entries for each master key to try it one by one. So let me replace the second one. Okay, and the third one, and the fourth one, the last one. Okay, I'll try this stuff one by one. Let's see whether it decrypts. Unpack requires buffer of 4 bytes while unpacking crypto algo. Okay, some error. Seems it didn't work. Do I have this DPAPI first? I do have. Okay. Second one also not worked. Third one not worked. Fourth one not worked. Fifth one not worked. I think I'm doing some mistake. Let's see. Unprotect file domain backup key related functions. Okay. Let's see. DP API master key related function. Master key file SID. So we can directly pass the system hive and the security hive in this, but what we did last time, file password SID, we passed all these details and grabbed it. Okay, how about using it to unprotect the data? I'm using correctly, but I don't know why I'm not getting it. Unprotect key file. So these two are essential components. So I dropped a key and I dropped a file. Okay. Okay, I guess 1, 2, 3. Okay, let's see. I guess I'm not getting any data from this cache 0. I was expecting to see some data, but let's see. 1, can't we see any data from this file? Let's see. I'll just replace this with this. Just last digit changes. Now I'll try this. Let's see. Unpack requires buffer of 4 bytes. What is the error? Some packet error. I could see some HTB forums write up. Am I new to HTB VM 4 and 6 MS equal entering this MS? Okay. I installed the package from repo pacman impacket. Is it an impacket error? Impacket MySQL client. Is there any solution? I recently got HTTP and this time pass. Thanks for the reply. Please don't post the results. Removing installing. Reinstalling the Kali, removing installing Python. Open service test. Let's thank you. I'm going mad. Same issue here. Tested and working indeed. Tried in both Kali. The problem was definitely server side, has now been resolved by service desk. I'm modifying your command to include the password like. Okay. Did they fix here? Not promising. Impact requires a buffer of 1 byte. Let's see this impact issues. Here is your test script. Impact. There is indeed a problem. I'm still struggling to find this. Let's see. Can I use it against a new blob? Same stuff. Is this? I think it looks like an impact error. Yes, it looks like an impact error. Come on. What can I do? UV, do I have any update here? UV tool upgrade -all. I'm trying to update my impact. Any updates for impact? I don't think so. Same error. Let's see. Shouldn't have added this. Let's see. Deep to John. What are they doing here? Perform offline brute force using users password using John the report. So it's also possible to recover the user's password from the user's password from the deep to John by simply cracking a hash, then recover it offline. Okay, now I'll try one thing. I was actually using this particular stuff. So here I was using this password. Let me use a wrong password intentionally and see what the response. No such file or directory. Okay. Master keys. Oh no. Protect master keys. Yeah. Now I'm using the wrong password intentionally and cannot decrypt, it says. So the password that we used was correct and it decrypted properly. The master key was cracked properly. But the master key, when I use the master key against the file, the blob, it is not recovering it. And that's the problem. Okay. Unprotect file. Okay, let's try the remaining stuff. Not works. Not works. Not works. Same results. And same results. Okay. Now no improvements, but we cracked the master keys. That's good. Okay. Now what can I do? Do I have an alternate utility? Let's see. Sharp dpappy. How about using sharp dpappy? Impacket and sharp dpappy. So impacket dpappy, master key file, system key, system hive, security hive. Okay. So they decrypt the master key. And now here SHA-1 hash of the decrypted system master key. Extract the private keys you want to decrypt. Cryptography private key. So here by using this master key, they are decrypting the cryptographic key. Wine sharp dpappy certificates target. So here they are uncovering the certificates. Okay. So here they are decrypting the Chrome password. Huh. Okay. Can I install this stuff? Let's try. Root. It's gonna take some time. Then I need to add an architecture. Then I need to add Wine32, Wine MSI exec, I Wine mono version. Install wine order in order to run dpappy. Sharp dpappy. Okay. Let's see. Looks like it is done. Can I add this? Permission denied. Done. Then Wine32. No installation candidate. Okay, now do I have wine here? I do have. Wine. Okay, I download this binary. Sharp dpappy. I store it in Latus. Okay. Wine. Sherlock's, Latus, sharp dpappy. Can I see it? Oh, great. I'm able to execute. I am able to execute this. File not found. Okay, awesome. I'm able to execute this. And now I go and use hyphen help or hyphen help. Maybe I should look the help menu. Sharp dpappy, please execute. You should install as a root. Please execute this app to get install this wine32 stuff. Let's see. Sudo. Okay, I need to install this. Come on, unable to locate the package. Search wine32 pipe grep wine. I don't see wine32 here. Come on. Sharp dpappy. Let me start this Windows machine. It's better to execute it in Windows. I don't see wine. Sherlock's Latus Sharp dpappy. So this one is missing. So if we execute, if you install this, I guess it will work. But since I couldn't spot this package, I'm moving on. Log in the Windows machine. Come on. So this is the library. This is the GitHub repo. Let me log in here. Okay, Sharp dpappy. Download this file. Dangerous download block. What? Settings. No protection. Turn off. Yes, I need to download it. Don't block it, Chrome. Yes, please. Download unverified file. What? Let's see. I turn off the real-time protection. Now it won't block me. Okay, I download this again and I could download. Awesome. I have this file. Let me rename this file to its standard name. Awesome. I actually opened this particular location in the terminal and let's execute this. Sharp dpappy. Yes. Show all decrypted private key files. Use local machine key certificate machine triage. Make file target. Make file password. Okay, let's see. Machine master keys, machine credential, machine qualter, machine triage. Search, register, type folder, type file, path to file, domain backup, no wrap, server file. Okay, now how can I decrypt this? First, decrypt the current user's master key using the plain text password. So this one, to do that, argument for credential vault RDG key pass triage blob ps. Okay, unprotect is the stuff to use. Okay, let me check my notes. Do I have any stuff here. um, Sharp chromium. Sharp chromium, DPAPI decryption. Blob, so this command they used to, I think they used Mimikatz to decrypt it. Okay, extracting the master key, DPAPI blob. So this one is to decrypt the Chrome password. DPAPI blob. So this is the command. If you're using Mimikatz, this is the command, straightforward. But if you are in offline cracking, then I think you should be taking a different approach. C sharp, lantern, ledger. Okay, I guess I should be looking at some other resources. Let's see. How about this? BMC tools, cache, bin, decrypt. And look at this. Here in this cache file, they are seeing the header RDP8 BMP. And let's see that magic bytes. RDP cat cache dot bin, sorry, one more zero, dot bin pipe xxt pipe head RDP8 PMP. So it resembles the same stuff. Then I decoded hex to ASCII to my first. Okay, so can we refer the same stuff? Cached bin file, you must figure it out. First of all, I downloaded the zip file, unzipped the file, and I got. Okay, so in this scenario also there is a bcache.bmc file and the cache 00.bin file. I don't know what kind of these files, so I searched for file extensions on Google. I got some basic knowledge of this file. Okay, after looking into the hex, I looked for the signatures. Okay, then I decoded the ASCII. All right, I got the two RDP because I know that the cached file of BMP images. So I searched around the Google for, I got the Python script to get those. Okay, so let's use the same script here. I think this tool automatically refers that BMC file from the current directory. So say I'm simply passing that yeah, college of image file, I got the flag in that. Okay, so let's download this tool, RDP bitmap cache parser. So what it is, let's learn this. RDP bitmap cache parser, what it is. It's a tool used to digital forensics to extract the RDP bitmap cache files found on client machine connected to remote RDP servers, store cached graphical elements from the remote session, improve performance, reduce network traffic. So the RDP session actually cached some image files, and those image files can be cracked by using this utility. Okay, fine. I download this utility. Let it download here. Git clone BMC tools. BMC tools. Where is my notes? Okay, I'm also referring this blog. Mm, uncovering RDP bitmap images. Okay, and I use this command. Let's see. Um, okay, Python bmc tools.py -s -s let's see. Okay, um, Python bmc tools -s okay, I'll move this tool to a previous directory. um, okay, from here I use this bmc tools -s -s, okay, -d dot. Cannot find main module in bmc tools. Hmm. Oh gosh, was dumb. Processing a file, cache.bin. Now let's see. All right, successfully exported 6539 files. That's massive. Bunch of BMP images. Come on. Huh. Can I open any of these files? See, bunch of images here. Nautilus dot. I could see bunch of truncated screenshots of this RDP. So with this, what I could do? These are all the pieces of RDP session. With this, I cannot do anything, right? Oh gosh, so many. Keeps going. Huh. So this particular stuff make dir BMP files. So I'll move all those BMP files there. Bitmap files. BMP files. Yeah. All right. I guess even if I decrypt those remaining two cache files, I don't think I get anything. Let's see. This file looks small, so let's try this. Yeah, like this. Processing a file. 4083 files again. Huh. Nautilus dot. It's just a piece of a screenshot. I don't think it's useful. Once again, I move every files to this directory. And how about this one? Let's do this as well. It's processing. Okay. Same stuff. Okay. I guess. Come on, that's a lot. Okay. How about this? Particular file. I don't think we get anything of this. Can I decrypt something else? Like, let's see. Where RDP credentials get stored. I need to know the location of it. RDP credentials is stored in Windows. Windows credential. RDP credentials in the Windows are primarily stored in the Windows Credential Manager and the Windows registry. The Credential Manager stores the saved credential. Okay, so we should also be seeing the Credential Manager here. Okay, let's see. Terminal server client servers, terminal server default. Windows. This is the Windows registry, and store the plain text. Typically DPIP data, but credential for remote desktop connections. Let's see. In this official blog, do we see any details? Let's see. How to delete the saved RDP credential? Any way to retrieve the password from RDP file? Location or path where RDP session credential details get stored. Terminal server client. Windows registry, terminal server client, forwards defaults. When you save RDP connection, the settings include the stored in the .rdp file. The credentials within .rdp file typically encrypted. So why don't we check for the file that ends with RDP? I think in this particular tree, let's see. I see bunch of document default.rdp file. let's see. I see two default.rdp file. I can see the Mimikatz binary as well. Let's see. Um, what's the file name? Um, default.rdp. I go to this directory. Okay, find file. Sorry, find name default.rdp, type should be file, and I'm just devnulling the errors. Okay, let me grab this. I think it is there in the documents folder. Let's see, users eman.t, sorry, eman.t documents folder, default.rdp. I grabbed it. Copy default.rdp to Sherlock's Latus eman.t rdp. All right, and where else? I'm having this in one more place. Eman documents and one more rdp file. Okay. Copy default.rdp to Sherlock's Latus. Okay, I'll do one thing. I'll create one directory. Make directory Sherlock Latus eman, and here. Okay. All right. Now I have these files ready. I have this default.rdp. Let's see. File. If I cat this, what? I see readable data. But I don't think this file matters now. Huh. File stores rdp blobs. .rdp files are the configuration files. Disable wallpaper, compression, any interesting stuff of this. Alternate shell. So it's a configuration file apparently. Any other interesting file that I need to look at? Where are the RDP files stored? Documents folder. Okay. What is the file to Azure Blob Storage? File stores RDP credentials and um, session details. So if nothing works out, I'm going to try this against the credential and the vault files that we already extract. Hopefully that will be giving us some data. Um, how to find stored credentials. Okay, I go here, I go to the credential manager. Let's see. I go to roaming. Anything else? No. No. Local credentials. So we need to uncover this. Let's try it. Okay, I again go to this particular um, blog. Here again I use this particular command. Okay, I go to the end. Here I just replace this with and okay, and what next? Okay, fourth key. Okay, fifth key. Um, oh gosh, come on. I think I should be trying against the same blob because I have multiple master keys. Paste, paste, and paste. Now let's try this. No, some error. I think this error is the error is in dpappy dpappy.py packet script. Unpack requires a buffer of 4 bytes when unpacking field crypt algo. Come on. Frustrating. Function attempting to read the 4 bytes of crypto algo field within the dpappy structure. Crypt algo field. But provided data buffer is either too short or malformed. Dpappy blob file processing the crypto algo field. The error message unpacking field crypto algo impact suggests the issue is passing the processing data related to crypto algo field of dpappy script. This indicates the script is 4 bytes. Okay, the corrupted and incomplete dpappy data. Mismatch or compatibility issues, bug in impact. Um, let's see. Hmm. Crypt algo. I search with this. I see something in a closed. Mm, depack pappy. This line should change to unhexlify self options key to unhexlify self option dot key. What is there in my script? Um, which dpappy? Um, I open it in Sublime Text. Let's see. What is the line number? 409. Okay, I'll search with this. Um, unhexlify key equal to unhexlify self. With this. Okay. Huh. So this is what they were talking about. Key equal to unhexlify self options key 2. Can I modify this to this? Let's see. I comment this out. I save this and try again. Not works. So I restore. I come out. Uh, I hate this. Hmm. Okay. I should be looking at the other files that could be storing the data. Or to decrypt this, can I use sharp dpappy now? Maybe I could try that. Let's see. Unprotect file key. Okay. Let me check for the tool sharp dpappy and its commands. Sharp dpa, come on, sharp dp api. um, I should be getting its menu. Master keys are located in the following path. Okay, we extracted that. um, the encrypted keys can be ingested into Mimikatz. So again, they are talking about Mimikat. Master keys RPC, sharp dpappy. Domain backup key. Master key files can be imported to dploot, browser, purple lab administrator, dploot master keys, donpappy. Okay, another incredible tool. donpappy is actually an incredible tool to decrypt this dpappy stuff. So it will capture all those relevant files automatically and it will decrypt it for us. But here, since we are manually grabbing the files from this mess, it's taking a lot of time. Okay, I'll check whether I can get any other interesting file here. The RDP gets stored in the I'm seeing this blob here, but okay, now unprotect, force use of crypt and protect data. I need a complete command to uncover this. Share dpappy backup key no wrap server domain. So this is actually to try it in the live stuff. Type registry file path to file. This one is to search. Machine master key, machine credential, machine vault to machine triage. I need a sharp dpappy commands. Sharp dpappy commands. Let's see whether I get anything. Commands or cheat sheet. Let's see. Spectre of Ops Pro. Search type folder program files demo. Blob master key. Okay, so this is what I was looking for. So here I should be mentioning the blob followed by that blob and the master key. Okay, so this is what I should try then. Let's see. I go to my notes, take this notes, sharp dpappy.exe. The blob is this, and oh sorry, the blob is this particular file, and master key should be given here. Now in that machine. I should navigate to the extracted directory, users, like this, app data, local, come on, connected devices platform, what it is. So we should be looking at this. But should be checking at Microsoft, and here terminal server client was holding this cache of this. I was able to extract just the image files, not more than that. Windows history, ringtones, roaming, Winx history, game explorer, cache burns. Okay. Vault, user profile, roaming, and some data, credentials, roaming, Microsoft, credentials, nothing. Okay, I go to this local, where it is, Microsoft, credentials. So these files are hidden. So I need to I'm cding into this directory, and now gci-f force, and now I could see the hidden files. Okay. All right, so this is where I need to execute this binary. I go to Latus, not Latus, downloads maybe. Gosh, where did I add this sharp dpappy tool? I downloaded it. Users, my name, downloads, no. In which folder it is? Downloads sharp dpappy. Okay, I'll go and download it here. Sharp dpappy, where it is, yeah. Come on. I think it removed it. I should turn it off. Now I download this. Let's see. And yeah, now I have downloaded this file. Okay, I copy this. I go it to Latus, and here I'm adding it. Okay, so this is the path, and me call this sharp dpappy. Okay, I could call this now, and I craft the command like this, blob and the key. So similarly, I should be trying this against all the keys. 3, 4, sorry. 3, 4, 5. Mentioning the second key, mentioning the third key, mentioning the fourth key, and mentioning the fifth master key. Now let me try to uncover this. Come on. Sharp DPAP completed. What is that? Non-negative number required. What? Okay, I think it worked well because it sees, I can see this stuff. I think it is actually the wrong master key to decode that. That's what I assume from this. Okay, now I go here, try to do it with another master key. Now let's see. Okay, it didn't work. Can I try it against? No. All 5 keys are not worked. If that impacket works, then it would have been very easier. I don't know what is the mistake that I'm making, but here I'm simply struggling to find this stuff. GCI hyphen force. Let me grab the second one. 6C. Sorry, not here. Here. 6C, 6C, 6C. So I'm trying to crack the second blob. The first one was not working. Okay, lot of struggles in this stream. I'm planning to wind up this stream here. I didn't get any breakthrough, but I accept this master key retrieval. I retrieved this master key, but with this master key I could not decrypt that blob. I don't know what was the mistakes that I was doing. I'm just trying to figure it out, but we were able to grab this, we were able to uncover this cache files, but it was not helpful. It was simply showing us that small truncated screenshots, not useful at all. I wonder where we can check next. I'm just trying to figure it out. I'll take some time, maybe come back in the next stream and try to sort this out. Any remote desktop related files? Remote desktop connections. So by extracting this event file, event log file, we will be able to answer a couple of questions, I guess. The first 3 IP addresses that E-man-T connected using RDP. So probably we can answer these questions by using this remote desktop logs. Yeah, let's see bunch of logs here. Terminal service RDP connection manager. Okay. Yeah, as I said, I'll stop this stream here. We will resume this stream again, solving this Sherlock. It's actually a new learning to me. I also tried to figure out what was that issue, because I could not use this DPAPI against this unprotect. It was not decrypting the data for us. All right. Yeah, I'll stop the stream here. Hopefully I'll be able to fix that DPAPI issue. Next time when I'm coming to the stream, I'll do some preparation. I'll try to solve it before itself, and I'll come and show you how to fix this issue and grab those RDP related details, RDP connection histories and credentials, everything. That's it for this stream. I'll catch you next time with another exciting one. Thank you so much.